Hi, I want to talk about a strategy for dividing polynomials called synthetic division. To get us there, though, I want to begin by refreshing your memory on polynomial long division. So let's do this problem. We're going to have x cubed plus 9x minus 7, and we're going to divide it by x plus 1. So recall x plus 1 is our divisor, so it's going to go out here. And our dividend will come right here, x cubed plus, notice I need a placeholder because I don't have an x squared term, so that means it's really 0x squared. And then we have 9x minus 7. So here we go. Remember, we look to see what we need to multiply by x to get x cubed, and that is an x squared. Unlike arithmetic, where it really matters where you put the number up here, when we're doing polynomial long division, it doesn't really matter. Some books will put it here, some books will put it here. I prefer to put the x squared above the term that has an x squared in it, so I'm going to put it right here. And then we multiply our x squared by our x plus 1 and write that down. So we have x cubed plus x squared, and then we subtract. So our x cubed minus x cubed is 0. We have 0x squared minus x squared. That's the opposite of x squared. We bring down our 9x, and we repeat the process. What do we need to multiply by x to get the opposite of x squared? That's the opposite of x. And now I multiply the opposite of x times x plus 1. So we have the opposite of x squared minus x. Again, we subtract. And we have positive 10x. Take care here. It was 9x minus a negative 1x, and that gives us our 10x. So we'll bring down our negative 7 and repeat the process one more time. What do we need to multiply by x to get 10x? That's a 10. So we put a positive 10 up here. We multiply, and we have 10x plus 10. And we subtract. And our negative 7 minus 10 is negative 17. And we have completed the division. Now, the way you present your answer depends on what's required for the problem or what you're going to use it for. But let me refresh your memory on the two different ways that we could present the results. We know that x cubed plus 9x minus 7 is equal to the product of the divisor and the quotient with the remainder added in. So let's write that down. We have x plus 1 times x squared minus x plus 10 plus negative 17, or just minus 17. The other way we could write it is this. We could have x cubed plus 9x minus 7 divided by x plus 1 equals, and now we will write our quotient right here. So we have x squared minus x plus 10, and then our remainder over the divisor. And make sure we put a plus right here, negative 17 over x plus 1. And of course, we could, instead of had a plus negative 17 over x plus 1, we could have just written it minus 17 over x plus 1. Either way. But now we're going to move to synthetic division. We're going to do this exact same problem synthetically. Now, a synthetic division allows us to do a problem like this in a more compact fashion. And by problem like this, let me make sure I'm clear about what I'm talking about. I'm talking about a problem where the divisor is first degree. That means the exponent right here is a 1. We don't have an x squared or an x cubed down here. It's first degree, and the leading coefficient right here is a 1. That's what we're going to use synthetic division for. Divisors that are first degree and leading coefficient is 1. And it allows us to eliminate a lot of the duplication in writing. Let me point out a few of the duplications here in the problem we just did. Right here, there is a coefficient of -1. That's the same coefficient as right here, -1 and a -1 here. This 10 we also see right here and here. Synthetic division will allow us not to write those numbers so many times. Additionally, notice how many times we've written x squared. We have an x squared column, we've written it a bunch of times. Here's our x column, we've written x a number of times as well. So synthetic division, again, will allow us to write this problem in a more compact fashion. So here's how it works. I'm going to come over here to the right and we're going to do the same problem using synthetic division. So I'm going to start by drawing a box right here. And in this box, I'm going to put the number that makes the denominator 0. So notice here, I'm looking at the divisor. The number that would make this 0 is -1. So -1 goes right here. Now next to it, I'm going to write all the coefficients of the dividend. So those numbers would be 1, 0, 9, and -7. So 1, 0, 9, and -7. And now I'm going to leave a little space, and then I draw a line. And now I'm going to start the process of synthetic division. And here we go. We bring down the first number down below the line, and the 1 will come here. Multiply this number by the number we just brought down, so -1 times 1, and we'll write it right here. That's -1. And then we add. So 0 plus -1 is -1, and we repeat the process. Multiply. That's a 1. Write it down right here. And add. Repeat the process again. Multiply. Write the number down right here. And add. And the number that we get right here will be the remainder. And the coefficients of the quotient will be right here. So notice what we find. The quotient would be, based on our synthetic division, the quotient would be positive 1x squared minus x plus 10. And our remainder is -17. And notice that's the same result that we had when we did this problem using long division. And notice I just popped in the quotient and remainder and wrote it this way, but we could have written the result either of these two ways that I already have it written here. I just wanted to point out that the quotient and the remainder were exactly the same. Let's do another problem. Let's use synthetic division to divide this problem. And notice I have the division problem written horizontally rather than written as a fraction. It doesn't matter. The process is still the same. So I'm going to write the 3 here. Remember, it comes from this divisor. It's the number that makes it equal to 0. Or another way to think of it is the opposite of this number. We see a -3 or a -3. That means we have a +3 here inside the box. Now I'll write the coefficients of the dividend. So they are 5, -7, 0, and 25. Don't forget the 0. It's because the coefficient of our x must be 0 because I don't see an x to the first power. So we need to include that 0. And now we draw a line. We skip some space or leave some space right here because we know there are going to be some numbers that need to be written. And I begin the process. Bring down our first number. That would be a 5. We multiply these two together and write it down right here. And now we add. Repeat the process. multiply, write it down, and add, multiply, write it down right here, and add. Now our remainder is sitting right here. And these are the coefficients of our quotient. So now it wasn't given to us what way we should present the answer, so I'm just going to choose. I'm going to write the result this way: 5x cubed minus 7x squared plus 25 equals the divisor, x minus 3, times the quotient. Now remember where you get the quotient? These are the coefficients of the quotient right here. The quotient always is 1 degree less than your dividend. This was third degree, so this will be second degree. So this is the coefficient of our x squared term. So we have 5x squared plus 8x plus 24. And our remainder is 97, so we need to add that in. And our problem is complete. Let's do this problem next. Use synthetic division to divide. So let's roll through the process. So I need a -2 coming from this divisor over here in the box. And then my coefficients for the dividend are 1, 3, -8, -17, and 6. And I'm going to draw my line right here. And let me just mention that there is variation between books about how they present synthetic division. Sometimes instead of putting the 2 in the box, as I did right here, some books put the box around these numbers. It can vary, but the process is really the same. So let me continue now. So we're going to bring down our 1. Don't forget, that's how you begin. Bring down your leading coefficient of the dividend. So I bring it down, and now the process begins. Multiply these two together, write it down, and add. Multiply and add. Multiply and add. Multiply and add. And here's my remainder. Hey, notice the remainder is 0 this time. Well, what does that tell us? Well, it tells us this. Our x to the 4th plus 3x cubed minus 8x squared minus 17x plus 6 is equal to x plus 2, our divisor, times our quotient. Remember, here are our coefficients of our quotient. The degree of the quotient is 1 less than the degree of the dividend. That's 4th degree. So this will start with 3rd degree. So I have 1x cubed plus 1x squared minus 10x plus 3. And I'm not adding in a remainder because our remainder is 0. And what we see is that x plus 2 is actually a factor of this dividend, because this dividend is the product of x plus 2 and this polynomial. So now we have a way to easily determine whether some first-degree polynomials are factors of other polynomials. And let's do a final example illustrating that point. So the directions say to use synthetic division to determine whether x minus 5 is a factor of 2x to the 5th minus 45x cubed plus 2x squared minus 660. So here we go. Our task is to determine whether the remainder is 0 when we do the division. Remember, if the remainder is 0, it means it went in evenly and it's a factor. If the remainder is not 0, it didn't go in evenly, so it's not a factor. So here we go. We're going to put 5 right here. And now we have all the coefficients of the dividend. Why don't you pause the video and try it on your own, and then peek and see if we get the same results. So now here we are. 2, 0, negative 45, 2, 0, and negative 660. If you did this on your own, did you remember to put in those two zeros? We needed a 0 for the x to the fourth and a 0 for the x to the first for the coefficients of those terms. So let's draw our line. We bring down our 2, we multiply and add. Oops, that's a 10. I was anticipating the next product. 10 times 5 is 50. And we add, multiply, and add. Multiply, what is that, 135? And add. Multiply one last time. What is that, 675? And add. And we see we have a remainder that is not 0. So we know that x minus 5 is not a factor of 2x to the fifth minus 45x cubed plus 2x squared minus 660. I hope you'll go do some problems using synthetic division.